So first off, we're gonna have to understand what an AGV is. So AGV is an automatic guided vehicle. It can transport materials and products at a manufacturing center by using paths or navigation based on wires on the surface and magnetic strips.
So building the robot, so the sensors that we used that made this whole thing run was the line trackers on the bottom, which are these red things. And so the first time we did it, we put all the sensors, after we coded it, all right next to each other, right up at the front of it, or at the back of it, and then we found out that it would turn too late. So at that point we split them, so they would be at the same horizontal thing, but they would be split apart in bigger intervals. That also didn't work because that still did the same problem of not turning fast enough, and it would get all the sensors would be on white, which would just cause the robot to stop moving. So at that point, we took the two sensors on the side and dropped them to the very front of it. So in this case, we're able to make the sensors sense the white earlier. So then the middle sensor will be able to turn faster and won't have to make one huge turn once it registers white, and they can just make little small adjustments. And yeah, that's why we moved them all the way to the front. And this is just a list of the tools that we use, you know, with like the screws, the screwdrivers, metal, and all that.
Okay, so for the coding process, what the big thing that we had to use was an if and else cycle. This means if you take a code and you say if this happens, then this else this will happen. So with the line tracker code, we had to say if these sensors sensed the value of the white, then we would have to, then otherwise or else it will turn the wheels at a different speed and make the vehicle turn in a direction to keep it on the path. So this statement, we had to set it to the right tracker to less than 550, because that was what the white values came up as on the line tracker. And then the left, when that right tracker senses that, it will turn the wheels forward at 60 on each one so that it will stop and turn left. And then the same thing for the left value. If it senses 550, it will turn right. So that's just a picture of the bottom of the AGV as shown earlier by Marlon. And then this is the tracker code right here. So if the F sensor value of left sensor is less than 550, the right and left motor will turn backwards at 60, and it will make it turn right. And then if sensor value is right sensor is less than 550, it'll turn left. And if they all sense greater than 600, which is black, they'll move straight forward at 30.
So this is how you connect the wireless controller. So this is a wireless controller, and this USB will connect to this USB. So basically, you call it step 1, you connect this USB to the test and one to the controller. So when you turn on the back.
First you have to download the code to the robot, and then you can do all this.
And then now you turn on the controller and you wait for 3 LED lights.
And then once it turns blue, that means the connection is established, and then in a little bit, you know, if I did put it on the floor, it'll start running since it was sense the black.
So these are buttons we use. So we use buttons 6U and 6B to control the arm of the robot, and we use button 5U and 5B to control the claw, the opening and closing of the claw. And the thumbsticks right here help us guide the vehicle.
And this would be for the manual part of the vehicle rather than the automated.
So this is just, again, the line tracker code saying autonomous refers to it being independent without having to us actually using the controller. It would actually just run the code by itself and move by itself. So these robots are intelligent enough to do these tasks by themselves, and that's why they're used in manufacturing companies.
Oh, this is the manual code. So we set, same thing. So we set the controller, we set button 6 to open the claw, and then button 5 to move the arm over.
This would be the claw, and this would be the arm, so it would go up, and then the claw would open.
And this is the manual code. Joysticks, like Varun said, up, forward and backwards, claw, arm, same thing.
gonna demonstrate.
Oh, that it worked. So now we're going to demonstrate it. Okay, so first I turn on the Cortex on the robot.
Then I turn on the remote.
Line it up, and then once the thing turns blue like that, it'll start running in a couple seconds.
After control, connects to control.
And as you can see right there, whenever the left sensor sensed the white, it would stop the left wheel from turning, and it would turn the right wheel so that it would make sure it turned right and keep it on track.
Putting the line trackers out front, that allowed it to, because what happened before would be it registered too late and it would have to turn completely, and at that point, it's not even parallel to the next path. So at this point, putting it forward, we can sense it earlier and make small adjustments earlier.
And it'll keep going until it senses white, so that's why it was.
That's it.